we can say the cost of, purchasing the bottles is dependent on the number of bottles you buy. So that means the number of bottles will be our X amount. The cost will be the Y amount. Or we can write it out as a sentence saying, so the cost is the dependent variable, which we use to represent with Y, and the number, I'll use a number sign for that, of bottles is the independent variable, or the X. A few other strategies that you can use to help you identify the independent variables versus the dependent variables. We have a few common quantities that we will be measuring, or types of units. If you see anything about time, whether it's months, years, days, weeks, hours, seconds, we cannot control time. So time is usually going to be an independent variable. And that's because time passes whether we are measuring it or not, whether we're trying to make time move faster or make it move slower. We cannot control time. Time is independent. It is not affected by anything else. On the other hand, something that is affected by our choices is money. This is usually money spent or money earned. This depends on how many items you are buying or how many hours you are working. Money is usually going to be a dependent variable. So if you're encountering a word problem that either talks about time or that talks about money, you can usually pretty quickly identify that time would be the independent variable, or the X, and money, if it's included in the problem, would be the dependent variable, or Y. Now, there could be exceptions, but in general, this is something that will be fairly consistent. Now, on the back, there are several more examples for us to identify. In this, we need to first figure out what we want to have represent our X, or the independent variable, and Y, the dependent variable. Then we need to practice building the table, simplifying the ratio of the Y values over the X values, deciding if the problem is or is not proportional. If it is proportional, then we can calculate the constant of proportionality and decide the equation that represents it. If when we go through this we realize this is not proportional, then we cannot find the constant of proportionality or find the equation. There might be other equations that represent the relationship, but it's not a type of equation that we've learned about yet. So let's look at example 3. So this says, a sponge is a filter feeder. It takes in food by filtering water through its body. The sponge has a constant flow of water through its body. In the first try of his biology experiment, Scott recorded there are 8 liters of water flowed through the sponge in 10 hours. He tried the experiment again and recorded 12 liters of water flowed through the sponge in 15 hours. So if we're looking at this, we're given information about the amount of water, the liters of water, and the amount of time in hours. So those are the two quantities that we are working with in this problem. So we need to decide which of those quantities will be X, the independent variable, and which of these quantities will be Y, or the dependent variable. So if we're looking at this, the amount of water is one item. The time that passes is our other item. In this case, like what we talked about on the other side, if we look over here, time, we can't see that, here we go. Time is the independent variable. We cannot control time. Time is always independent. We cannot make it go faster or slower, so time will be our X. In this case, we want to specify, so this is time, and this is measured in hours, as opposed to days or weeks or minutes. That means Y will be the liters of water. So now that we've decided that, we can go ahead and record the information for each of these measurements in the specific rows. So in our first row, the amount of time that passes is 10 hours, so we'll put that under X. The liters of water with that is 8, so we'll put 8 under Y. For the next row, we have 12 liters of water and 15 hours, so 15 is the time, so we'll put that under X. For Y, we'll put 12 for that. Now we need to set up our ratio. So the ratio is going to be the Y value over the X value. So we have 8 over 10. And we want to simplify that. In this case, we can simplify this we could divide those both by 2. So we'll end up with 4 over 5. Or if you were to use a calculator, you would end up getting 0.8. Or 0.8 over 1 if you wanted to keep it as a fraction. For 12, for this next row, we would put the 12 on top because that's the Y value. That would be over 15. And if we simplify this, 12 and 15, we can divide those both by 3. So 12 will turn into 4. 15 divided by 3 will give us 5. And 4 over 5, that's equivalent to 0.8 over 1. So if we're comparing this, we can see that these ratios are equivalent. That tells us this is a proportional relationship. Because this is proportional, we can identify our constant of proportionality. We said that will always be the numerator of our unit rate. So since this is the numerator of our unit rate, where we have a 1 in the denominator, K, the constant of proportionality, will be 0.8. And we'll use that in writing our equation. Instead of Y equals K, we'll say Y equals 0.8 times X. So we've successfully found the equation that represents this scenario. And we'll actually be able to use this in the future to find out how many liters of water would pass after 20 hours or after 100 hours. So this allows us to really quickly calculate other entries into the table. Let's look at example 4. Example 4 says the total cost for admission and rides at the amusement park is given at the ticket booth. It says, welcome to the fun fair. Admission is $20 and each ride costs $5. So we are being told that X will represent the number of rides that we choose to go on. So based on how many rides we go on, that determines how much money we have to pay. So Y will represent the total cost. And sure enough, if we look at the table, we can see if we choose to go on one ride, we would pay $20 to get in and $5 for the one ride, so we would pay a total of $25. If we wanted to go on 2 rides, we'd pay the $20 to get in plus $5 for each of the 2 rides, so that would be $10 extra dollars. So altogether, we would have spent $30. If we wanted to go on the 3 rides, we'd pay the $20 to get in plus $5, $5, $5 for each of those rides. So altogether, we would spend $35. So we can set up our ratio of the Y value, the cost in dollars, over the X value, which is the number of rides. So this would be 25 over 1. We don't have to simplify that at all because it already is simplified. So we can move on to the next ratio. So we put the Y values on top of 30 over the number of rides, which is 2. This we can simplify. We can divide those both by 2. So we'll end up getting 15 over 1. And for the next, we can set this up 35 over 3. We cannot simplify that at all, so we'll just leave that as is. So if we are comparing our 3 ratios, we can see 25 over 1, 15 over 1, 35 over 3. These are not equivalent to each other. They are different from each other. So this is not a proportional relationship. So because it is not a proportional relationship, we cannot find the constant of proportionality, and we cannot find the equation. It is not possible for us to come up with that information at this point. So again, if when you're looking at the ratios of the Y values over the X values and you simplified them down, if they are not all equivalent, then it is not a proportional relationship, and we cannot find the constant of proportionality or come up with an equation. Let's look at this last example here before we get to our last type of problem. So this says these are the prices of lettuce in a farmer's market. So we can see 2 heads of lettuce cost $1.58. 3 heads of lettuce cost $2.37, and 6 heads of lettuce cost $4.74. So we're comparing the number of heads of lettuce to the cost. And if we think back to what we wrote on the other page, the amount of time spent is usually an independent variable. We're not measuring time in this problem. The amount of money is usually the dependent variable. In this question, one of the measurements is the money, the cost of buying lettuce. So the money, the cost, will be our dependent variable, the y. That means x will have to represent the number of heads of lettuce. So we can record this data here in the table. So x will represent the amount of lettuce. So we have 2 heads of lettuce, we have 3 heads of lettuce, we have 6 heads of lettuce. And then the y will represent the money that we would spend on that amount of lettuce. So for 2 heads of lettuce, we would spend $1.58. 2 heads of lettuce, we would spend $2.37, and 6 heads will cost $4.74. So we can set up our ratio. So it'll be the y value over the x value, so 1.58 divided by 2. If you go through and use a calculator or do the long division work by hand, we'll get 0.79 over 1. Our next ratio we'll set up will be 2.37 over 3. And if you type that into the calculator, if you divide it out, you'll end up getting 0.79 over 1. And for this last ratio, we would set it up as 4.74 in the numerator, 6 in the denominator, and if you divide that out, you'll end up getting 0.79 over 1. So if we are comparing these ratios, we can see that they are equivalent, which means this is a proportional relationship. So we can identify our constant of proportionality by looking at our unit rate. Whatever is in the numerator, that is our constant of proportionality. Or our simplified ratios are the constant of proportionality. So K will be 0.79. So we can write our equation. It's always going to be in the form y equals K, the constant of proportionality, times x. So in this case, this would be y equals 0.79 times x. Now, like I said before, we can use this equation to help us calculate other amounts of information. So if we look at number 6, we are going to use this equation to calculate how many liters of water flowed through the sponge in 30 hours. So that was not something that was measured. We can see Scott only measured how many liters flowed through the sponge in 10 hours and 15 hours, but we can take our equation. We always want to write out the equation. Our next step is to substitute in information from the problem. In this case, we were told how many hours we were working with. If we look back at example 3, we can see that hours is the x value. That was, we said x represents time in hours. So we want to put 30 in place of x because that stands for the amount of hours. So our equation is now y equals 0.8 times 30. So now we can use a calculator to multiply this out, and it turns out 0.8 times 30 will equal 24. So we can say 24 liters of water flowed through the sponge in 30 hours. So we can write our answer as a full sentence. Now we can do the same for the equation we came up with for example 5. It says example 5 continued. What is the price for 10 heads of lettuce? So the first step is to write out the equation. We said the equation was y equals 0.79 times x. So we just copy that same equation down here. Next, we need to substitute in the information from the question. So this question tells us we are working with 10 heads of lettuce. Well, if we look back at example 5, we said x represents the heads of lettuce. Y represents the cost. So if we have 10 heads of lettuce, we will replace x with the number 10 because that's what x represents, the amount of lettuce. So our equation will look like y equals 0.79 times 10. And you can choose to use parentheses, you could choose to use a dot, but we do not want to use x for multiplication because we're using x as a variable. That's why we do not want to use x as a symbol for multiplication. So now, all we need to do is do the multiplication work. So when we do that, we'll have y equals 0.79 times 10. That will end up being 7.